Last lesson we looked at dealing with lots of possible choices using if, else. However, this can become inefficient where you have many different choices. Most programming languages provide a simple means of writing a selection statement that provides many options like a menu system. This is called a switch statement. The idea is that you have a variable called your switch variable. You then run case statements, which are blocks of code that run depending on what is in the switch variable. Let's look at the menu choice case from the previous lesson. We have seen how to code this as an if, else statement. However, as a switch case statement, this code can be much more straightforward. Let's see this in AQA pseudocode. Firstly, we have the keyword switch, followed by our switch variable, which we've called user input. Notice that we use a colon after the switch variable to denote the start of our switch code block. This is quite similar to if statements in Python. Next, we have our case statements. We use the keyword case to start each case. We then put a value, for example 1 or 2, which is the value we're comparing to what user input is storing. Notice again that we have a colon after the value to denote the start of this case's code block. In the example, that is a print statement that will run when a case is true. After we have our specific case statements, we also have a default case. This runs whenever the other cases do not. This is like the else statement at the end of the if, else code. We then end our switch case code with the end switch keyword. The thing about switch statements is that they work on single variables only. By that we mean the variable user input could be just a number, or a letter, or a string. Unlike if, else statements, we cannot use Boolean expressions to perform more complex comparisons, such as this. You will notice I haven't given the switch case code in Python. This is because Python only recently added the capability to use switch case statements, and most compilers are not compatible with it yet, so you have to use elif instead. Sometimes after you've made one decision, you might want to make another, and this decision can only happen inside another decision. Take our first example about going to the cinema from our previous lesson. If we have more than £15, we are going to the movies. Once at the movies, if we are going to see the movie in 2D, we will check our change. If we have more than £5, we're going to get a large popcorn. Otherwise, we're going to get a small Coke. As a flowchart, this could look like this. If we were to write this in code, you would need to use an if statement within our if statement. This might look like the following. Notice how the new if statement on line 7 is indented underneath the print statement, and the code on line 8 is indented even further to the right. The reason is because the second if statement on line 7 will only run if the else statement runs if we go to a 2D movie. This is an example of a nested if statement. You know from previous lessons that the indenting in Python is critical, as it tells the compiler which lines of code belong to which if statement or else statement. Other languages use different techniques, like AQA pseudocode using then and end if to mark the start and end of the if block. Some languages use curly brackets. Even in these languages though, it's always best to indent for readability of your code. So, a way of dealing with selection statements with many options is a switch case statement. A switch case statement will not work with Boolean expressions, only single values. You can have one if statement inside another, and this is called a nested if statement. When you are nesting code in Python, the indentation becomes very important, as it shows to which if or else statement your code belongs.